Good afternoon, everyone, and welcome to the session number 6 from the playlist of JEE Advanced Part 1. The topic for the today's session is units and measurement. And with regards to this topic, I have taken one question which was asked in the JEE Advanced examination in the year 2015. And today we will be finding the percentage error in the measurement of the energy of a system which is given by this equation. So here the question is, the energy of a system at any time is given by this formula, that is E is equal to A square into E to the power minus alpha t, where alpha is equal to 0.2 per second. So the question here is, we have to find the percentage error in the measurement of the E at t is equal to 5 seconds if the percentage error in the measurement of A and time is equal to 1.25% and 1.5% respectively. So in this question, the equation for the energy of a system at any moment of time is given by A square into E to the power minus alpha t. So first of all, let us differentiate this equation with respect to t. So if I differentiate this equation with respect to t, I will be getting 2a dA upon dt into e to the power minus alpha t plus a square into the differentiation of this e to the power minus alpha t with respect to t. So this will be equal to minus alpha e to the power minus alpha t. So dE upon dt is equal to 2a dA upon dt into e to the power minus alpha t, and this will be equal to, since this, here we are getting minus alpha, so this will be equal to minus a square alpha into e to the power minus alpha t. So this equation can be written as dE is equal to 2a dA into e to the power minus alpha t and minus a square to alpha into e to the power minus alpha t dt. So this is the equation which I have got, and now what I will be doing is I will be dividing this equation by this equation, that is E is equal to A square into e to the power minus alpha t, and I will be getting the equation as dE upon E, this is equal to dE upon E, this is equal to 2a dA into e to the power minus alpha t minus a square into alpha into e minus alpha t dt divided by a square into e to the power minus alpha t. So this will be equal to, from here I will be getting this 2d, because this a and this will get cancelled out. So finally and this will also get cancelled out when I am dividing this by this. So I will be getting 2 dA upon A minus, so when I divide this by this, so I will be getting this as this A square into this e to the power minus alpha t. So this will get cancelled out both in this numerator and the denominator. So I will be left with the A square. Sorry, I will be left with alpha dt. So this is dE upon E, and this can be written as 2 dA upon A minus alpha dt. What I will be doing is I will be dividing this dt by t and again multiplying it by t. So this equation, this and this equation will remain the same. So here what I have done is I have divided this dt by t, and at the same time I have also multiplied it by t, so that both these equations remain the same. Now so from this equation we can write dE upon E into 100. I am just multiplying this equation on both sides by 100. So I will be getting as 2 dA upon A into 100 minus alpha t in bracket I am writing as dt upon t into 100. So this is the equation which I have got by multiplying the equation which was written below by 100 on both the sides. Now if the error is very small, then this dA upon A can be termed as relative error. Similarly, this dt upon t can be termed as relative error in the measurement of time. This dA upon A is a relative error in the measurement of A, and similarly, so dE upon E can be termed as a relative error in the measurement of the energy of this system at any moment of time. So, and we also know that the percentage error is equal to the relative error into 100. So this equation which is written here can be defined as that this dE upon E into 100 is the percentage error in the measurement of E, and this is equal to 2 times, now dA upon A into 100 is the percentage error in the measurement of A, so this is equal to 1.25. Now we know that while calculating the error in the measurement of any physical quantity, we add up all the errors, and so here in this case the error due to this measurement of A and the error due to the measurement of this time will be added up. So here the percentage error in the measurement of E will be equal to 2 times 1.25 plus alpha, the value of alpha is given as 0.2. We have to measure the percentage error in the measurement of E at t is equal to 5 seconds, and delta t upon t into 100, which is the percentage error in the measurement of time, so this is given as 1.5. So this will be equal to 2.5 plus this 0.2 into 5 is equal to 1. So this is equal to 1.5 and this is equal to 4. So the percentage error in the measurement of E at t is equal to 5 seconds is equal to 4%. So here in this question, the most important thing which we have to remember is that while measuring very small errors, we can differentiate this equation. Okay, and by differentiating this equation, in this question I have differentiated this equation with respect to t. So by differentiating this equation with respect to t, I was able to get the percentage error in the measurement of A and the percentage error in the measurement of the time in this equation, and by substituting these values which were given in the question, we were able to find the percentage error in the measurement of the energy of the system at any moment of time. So thank you very much for joining this session. In the next session, the topic will be the dimensional analysis. However, the chapter will remain the same, that is units and measurement. So till then, have a nice day. Bye.